For generations, water has been used for generating power. I've come now to the water mill at Blairgowrie, which is still in operation. It dates back from the 1500s and is used to power the mill behind. The amount of power you can generate is proportional to the flow rate, but also the height difference between the inlet and outlet, referred to as the head. If the head is high, you need only a relatively small amount of flow to produce a given amount of power. Scotland has numerous hydro stations, and there's potential for more, particularly micro hydro schemes. I'm going to have a look at two of these, one in Blairgowrie and another on the west coast. I've come to Brooklinn Mill in Blairgowrie to see one of Scotland's newest microhydro schemes and to see Tim Copeland here, who's actually constructed this. Can you just explain a little bit about it, Tim?
Yes, certainly. We've rebuilt the old hydro scheme, which has been here for over 100 years, and it's capable of producing around 100 kilowatts now. It is a relatively low head scheme, unlike many. It has about 12 metres head and will use over 1,000 litres per second at full power.
I've come to Ashfield Farm on the west coast of Scotland to meet Martin Foster, who set up 3 different hydro schemes.
This is the second machine at Ashfield. It's a single jet Pelton turbine doing 750 RPM, 500 kilowatts, and it was built in 2003. This is the outside of the Twin Lochs hydro, and you can see we don't use a lot of water because we've got such a high head. So we don't use a huge amount of water, and it's not hugely noisy, and I think our house is fairly inconspicuous.
The waves and currents around our coastline offer even greater potential. The CGen tidal energy converter has blades similar to those used on wind turbines to convert the kinetic energy of the tidal stream into electrical energy. The amount of power you can extract is proportional to the density of the fluid, so for a similar flow velocity and propeller size, a water turbine will generate more than 800 times more power than a wind turbine. The potential for generating power from water waves is also very great. The energy in a water wave is proportional to the square of the wave height, so there is much to be gained from operating in regions where the waves are high, such as off the west coast of Scotland. 3 types of devices have been successfully implemented in Scotland. The Limpet is a land-based system in which the motion of the incoming waves forces air through a turbine. Oyster is in the form of a flap which moves with the waves and pumps water through a land-based turbine. This is a shallow water device. Pelamis is a floating deep water machine with hinged cylindrical sections which move relative to each other in the wave motion and activate onboard generators. The technology of these devices is complex. Here are some pictures from inside a Pelamis module. Scotland has 2 pump storage schemes which are used to iron out irregularities in supply and demand.
I'm John Strettle, the production manager at Cruachan Power Station. We are now stood at the upper reservoir, and you can see the dam behind me. The dam is capable of holding 7 gigawatt hours of energy. Below us we've got Loch Awe, which is the lower reservoir, which is 400 metres below us. The water in the periods of surplus on the grid is pumped up from Loch Awe to this upper reservoir, and in times of high demand the water is then allowed to flow down from the dam through the generators within the power station and generate energy for the grid.